Hi, everybody. My name is Ms. Lee. Today we're going to be talking, or I'm going to be giving you an example of graphing quadratics from Vertex form. So the example we're doing is given the function y equals -3 times x minus 2 squared plus 8. We're going to list out the traits, the transformations, and sketch the graph. Actually, we're going to go ahead and start by listing out the transformations. You should remember this from last unit. Very straightforward. We'll start with the translation, the horizontal translation, because that's the first one we're always supposed to do. So that -2. What does x minus 2 do? Well, that would be a horizontal translation 2 units to the right. If you're in my class, obviously you do not have to put horizontal because saying right or left kind of tells you that it's horizontal, but it's not wrong to say that it's a horizontal translation. And then you know that we move from the translation to the dilation. So that -3 there, of course, that -3 will give you both the minus and the 3 are both going to give you different transformations. And they are interchangeable, so you know you can do them interchangeably. So we'll just start with the reflection. And so since this is a vertical reflection, that means that it's reflected vertically. And so which axis are you going across if the vertical, if the reflection is vertical? So vertical meaning it goes up to down or down to up. And so the axis that you're going across is across the x-axis. Now I know a lot of you are thinking, oh, x-axis is horizontal though. But yeah, exactly. You want to go across the horizontal axis to be able to be changing or moving vertically. So this is a reflection across the x-axis. And then that 3 is going to give you a vertical stretch by a factor of 3. And so that leaves us the +8. And that will be a vertical translation . 8 units up. Okay. And so now let's talk about a few of the important traits of the parabola. And so when we're graphing this parabola, as you know, usually it's a parabola and it's been shifted 2 units to the right. That means that the vertex is also shifted 2 units to the right. And then the +8 means that that vertex is shifted 8 units up. And so we know that the vertex then is going to be 2 from the translation right. So the x value goes right by 2. And then comma 8 because the y value goes up by 8. So again, the vertex will be direct results of the translation. And as you guys know, the axis of symmetry is going to be the line that goes through the parabola, and it's going to go through the vertex of the parabola. So if you have a parabola, the axis of symmetry is right down the middle. And so that's going to go through the vertex. And so it's going to go through, so you're going to want to write your axis of symmetry as the equation of a line. And if it's a line and it's a vertical line, that's going to be an x equals type of equation. And so an x equals type of equation through the point 2, 8 would mean that it would be x equals 2. So the axis of symmetry equation is going to be x equals 2. Again, the axis of symmetry is a line. You need to write that as an equation of a line. And so x equals 2, that's the x value of the vertex. Okay, we're going to also talk about the maximum value. And so if you have a parabola that has been vertically reflected, so meaning that it went from open up to open down, you now have a parabola that's open down. Is the vertex going to be a maximum or a minimum? So if you think about it, the vertex is going to be at the top of the parabola. So of course it's going to be a maximum. And so when you say that a point is a maximum, you will say that the maximum value is the y value of that point. In general, whenever you're asked for a value, you always use y values. So in this case, it would be 8. The maximum value of this parabola is 8. Okay, so we're going to go ahead and try graphing it. Okay, so we'll start by, of course, graphing the vertex. The vertex is 2, 8. And so when you're graphing a parabola, you need 3 points. So we'll go ahead and find the y-intercept because that's obviously an easy point to calculate. An easy point to calculate is the y-intercept. And from Algebra 1, you know that the y-intercept is the point where it intercepts the y-axis. And all the points on the y-axis have x values of 0. So you plug 0 in for x. And so we do f of 0 equals, and then we write -3 times 0 minus 2 squared plus 8. And so we have -2 in parentheses here, and then we square that and we get 4. So we have -3 times 4 plus 8. That would be -12 plus 8, which gets you -4. So therefore, f of 0 equals -4, meaning that the point on the graph is 0, -4. That's your y-intercept. So we'll go ahead and graph that. 0, -4. And so that's 2 points. That's not enough points to graph a parabola. To graph a parabola, you need 3 points. To graph a line, you need 2 points. This is not a line, so we need 1 more point. And so we were given information. We were given the vertex and the axis of symmetry. So we're going to go ahead and draw in that axis of symmetry. And so what does it mean to be an axis of symmetry? So an axis of symmetry is a line where all the points are reflected across this point. So if there's a point to the left of this line, then there's also a point to the right of this line in the same distance away. So if you're looking at this point here, you should see that it's exactly 2 units away from the axis of symmetry. And so what the axis of symmetry is telling us is that this parabola will also have a point 2 units away on the other side. So that would be over here. Okay, that's 3 points. We can now graph our parabola. Okay, so we're just going to go ahead and sketch this in. When you're doing this, please make sure that you keep everything smooth. No sharp turns or points. So make sure it's smooth, and also make sure your legs don't start like going outwards too much. Like make it a smooth sort of curve. And there we have it. We've now graphed our parabola from vertex 1.